All right, let's take a look. So, hyperbolas. So if you made it through that ellipse homework, then this will be nice, and in fact easier. No word problems in this section, and it's almost the same as ellipses. I think you'll find it nice. Not so bad as now that you've made it through those other two. Okay, let's go to the graph. We always need a graph, don't we? Graph really helps us as we make our equations. So let's put those foci. Can you put those on the graph real quick? So make a little axis system. Put those two foci points on there and see what you can do rather than me just whipping it out. Feel free to compare with those around you. Feel free to talk it out. Good for the two focus points. Hey, and where's the center? It's got to be the origin, huh? Yeah, because that's right. Those are right. Origin's right in the middle of those two, huh? Yeah, so center 0, 0. And right away, what do you know about the branches? Are they going up, down, or right, left? Up, down, because the focus points have to be inside, huh? So remember, it doesn't hit the focus points, right? You good with that? I don't know where it is exactly, but it's something like that. And something like that, these are vertex points, which we're going to need to find. But the focus points are inside somehow. The focus points are never on the graph. They're always inside the branches, aren't they? For all these shapes, right? Good so far? You comfortable with that much? So now, can you start writing the equation? Now that you know it goes up, down, that tells you something about the equation, doesn't it? So can you start with that? Can you write what you know so far on the equation? Yeah.
What does it mean by that?
Transverse, or what?
Oh, no, the asymptote, the line y.
Yeah, we'll get to that, yeah. Yeah, I don't think we went over it at all. Yeah, yet. I don't remember. But we definitely need to talk about it, yeah. So when I write the equation, since it's going up, down, what does that mean about the equation? Y is first, huh? Remember, it's all about who's first in the equation and who's second. Remember, the letter that's in front, the letter that's first, if it's up, down, Y is in the front. If it's right, left, X is in the front. Remember that for hyperbolas? Whoever's in front tells you the direction. Okay, great. So now, do we know anything more? What kind of step 2? What do we know? The hard one. I see. That's hard though. Okay, so yeah, let me help you with the asymptote line. Now the asymptote line equation is y equals minus x. What does that mean? Well, it's like mx plus b kind of thing. So what? Well, that means the m is minus 1. The slope. Am I going too quick? We have not talked about asymptote lines at all? This is our first. So asymptote lines, meaning there's some kind of dotted box here, right? Remember, I talked about the dotted box, didn't I? There's some kind of dotted box. I don't know exactly what it looks like. Whatever, blah, blah, blah. And then there's some kind of diagonal lines that are going through. Those are the asymptotes, right? This is an asymptote line? Well, it's a line, which means it's mx plus b. The equation of any line, remember from algebra? The equation of any line, any straight line that's not curved, has no curvature, is mx plus b. So what? Okay, well, you tell me. What's b when you're starting at the origin? Remember what b is in y equals mx plus b from your algebra days? What's b? The y-intercept, where it hits the y-axis. Where does this thing hit the y-axis? Where does this line hit the y-axis? At a height of 0. So b is 0. So it's just y equals mx. That's what they have here. You tracking with me? So the asymptote line is a line. So it means it's y equals mx plus b. And the b is 0 because it goes through the origin. So it's y equals mx. And sure enough, that's what they're giving me. And when they put a -1 in the front, they're saying to me, hey, buddy, -1 is the m. That's what they're telling me, right? They're saying m is -1. Which actually must be this one. They're telling me this one because this one goes down, doesn't it? This one is the one that has the negative slope. Whatever. They could have told me the positive one. I don't care about the sign. They're just telling me the slope is 1 or -1. The other one must be +1. Whatever. So what? So what? Well, do you know how you determine the slope of the... You know what makes the slope of those asymptote lines? What? Remember slope from your algebra days? What determines slope? Slope is what over what? Rise over run. Remember it's rise over run? Remember slope is rise over run? Slope is? So what does that mean if rise over run is coming out -1? Don't let the negative, just suppose it's +1. What if I said, hey, the slope, the m, rise over run, is coming out 1? What does that mean? If I say, hey guys, I'm dividing two numbers, it's coming out 1. What does that mean about those numbers? They're equal. They're equal. How else do you divide two numbers to get 1? They could be same number. I don't know what they are. 7 over 7, 8 over 8, 10 over 10, 12 over 12, whatever. Same number. Coming out 1. Or -1 means they're the same number, but one of them's negative, right? Same thing, whatever. I don't care about plus or minus. Everything's squared here, so I don't really care plus or minus. I just say, hey, they're telling me that rise and run are the same numbers. It's kind of tricky one, isn't it? So you got to catch that clue. They're telling you when they give you slope -1 or +1, which you got to remember slope is rise over run, and they're telling you, hey, the rise and the run numbers, they're the same. They're the same. Okay, so what? Where do rise and run come from? Where do rise and run? It's A and B. They're telling me A and B are the same. Why? Because remember how you make this box? Whatever's underneath Y is rise. It's how far up, isn't it? Whatever's underneath X is run. It's how far over to the edge. Remember what A and B are? Whatever's under Y is how far up, rise. Whatever's underneath X is how far over, run. So when we say, hey, rise, they're telling me the slope of the asymptote is -1, which means rise over run is -1, which means those two numbers are the same, which means A and B are the same. So what? Well, let's call them both A then, or call them both B. But they are the same. I can now call them by the same name. Because they're, and don't worry about the sign, plus or minus, they're squared, so who cares? Tracking with me? They're the same. They're cluing me in that those are the same numbers down there, whatever they are. Is that good, your question?
So you would have a different rise and run if the asymptote
Was not 1 or -1. Yeah. If the asymptote was like 2/3, yeah, good question. Good. I think it'd be helpful if I talked about that. I'm glad you asked that. Exactly right. Yeah, if they'd said, hey, your asymptote is 2/3 X, then I would have said, oh, 2 is the rise, must be underneath Y. 3 is the run, must be underneath X. Exactly. I would put those under Y and X, because rise, run, under Y, under X. Huh? I would know what they are. In this case, yeah, so if they told me 2/3, I would do that. But they're telling me 1, which means whatever they are, they're the same number. Now, it doesn't mean they're both 1. They could both be 5, 7, 3, whatever. They're the same number, dividing, simplifying to be 1. Right? So what? So then that means I can call these both A, because they are the same. So what? How does that help me? Well, put that together with one more tricky step. I'm going to write the, this is a pretty, I didn't realize it's such a tricky one. It's funny, some of them look easy and they're hard, like this one. Some of them look hard and they actually fall apart real quick. It's even hard for me to tell. Anyway, I'm going to go to the focus equation. Remember what's the focus equation? A squared, it's Pythagorean, isn't it? Remember, it's plus. It's exactly the Pythagorean. Because it's always the opposite sign from the original. The original is minus. This is plus. It's always the opposite sign in the focus equation. Remember that? Okay, so here's the focus. So what? Well, that means this is a squared plus a squared. Remember how I determined that a and b are the same? That'll help me solve this thing. I can't have them different. Okay, now what's c? What is c? 8, exactly. Everybody see c is 8? What is c? What does c stand for in all these formulas?
Center.
How far from, no, not center. It's how far from center to focus. C is focal distance. Right? You tracking with me on that? A and B are how far from center to edge. C is how far from center to focus. In all these equations. One more time. A and B are how far from center, right? This is A and B here. A and B is how far from center to edge of box. That's going to be what's under X, because it's sideways. That's A, and how far up, that's B. Right? A and B are how far from center to edge, from center to edge. And then from center to focus, that's C. C is how far from center to focus. And all these formulas. Okay, so how far from here to there? Well, it's 8. It's up at 8. So this is 8. A squared plus A squared is 8 squared. I can solve that. See how I had, if it was still A and B, I wouldn't be able to solve it. I couldn't handle 2 letters. You see why it was crucial? Then I realized these were both the same, and I called by the same letter. If it was A and B still, I'd go, A plus B is 8. I don't know. What are they? But now it's A squared plus A squared is 8. Yeah, that I can solve. 1A squared and 1A squared is 2A squared. 8 squared is, what, 64? Good so far? What I did there, I just add like terms, 1A squared, 2A squared. Just adding like terms. What do I do next to solve for A? Divide by 2. A squared is 32. And root it, plus or minus. A is plus or minus root of 32. Do you know how to, are you good at simplifying? Let me bring it over here. So one more time, let me just run this over again. A squared plus A squared is what? 8 squared. That's the formula we had right here. Right? Came from A squared plus B squared is C squared. Came from A squared plus B squared is C squared. We knew C was 8 and A and B are both A. So then I solved it. I go 1A squared is 2A squared is 64. Divide by 2. A squared is 32. Root it. When you put a roof in the house, up and down the ladder. So A is plus or minus root 32. Now, how do you simplify root 32? Do you remember from your algebra days? Those glorious algebra days? Break it down. 4 times 8. 2, 2. 8 is 2, 2, 2. Break it all the way down to its basic pieces. Remember, and I tell my algebra it's 2 for 1 deal. So 2 2's in, 1 2 out. 2 2's in, 1 2 out. The leftover 2 must stay in. So it's plus or minus. 2 times 2 comes out, 4 root 2. Remember that from algebra? Right? This 2 and this 2 multiply. It's 2 for 1. It's like shop. I always tell my algebra, it's like shopping at Target. It's a 2 for 1 deal. 2 2's in, 1 2 out. 2 2's in, 1 2 out. That's why it's called a square root. It's a 2 roots. 2 for 1 deal. So plus or minus 4 root 2. So there's what A is. It's plus or minus 4 root 2. So what? Well, that's everything actually. Yeah, because if you come back over here, that means the equation A squared is 4 root 2 squared. They're both the same, remember. 4 root 2 squared. What is 4 root 2 squared? That tricky question? 4 root 2 squared? 4 root 2 times 4 root 2? 4 times 4? 16. Root 2 root 2? Plain 2. 16 times 2? 32. Right? Is that good? You tracking with me? Those are really 30. I can make this 32 and make this 32 is my point. That's what 4 root 2 squared is, right? Want me to show that more clearly? 4 root 2 squared is 4 root 2, 4 root 2. Remember your root rules? Maybe not so much, huh? From algebra? You got to multiply the whole numbers with the whole numbers and the roots with roots. 4 times 4 is 16. Root 2 is root 4. And that's 2. And that's 32. Remember how to handle roots from your algebra days? So root 2. Or you could just, probably easier, just square the 4 and remove the root. That's probably easier. 32. Just square the 4, remove the root. 32. So we're basically done then. So this is 32 here. This is 30. And they wanted the equation, right? Yep. And we got it. What's the transverse axis? Maybe I should have answered that. What's a transverse axis?
That's where the graph is.
Yeah, where does the graph sit? On which axis is it hitting? The y-axis. The transverse is the y, yeah. And then they want the equation, which we have now given them. Kind of in a big mess. Sorry, that's pretty messy. There's the equation, and we got the graph. Yeah?
Say that again about the transverse axis.
Transverse axis is the axis it hits. See this branch? Which axis is he hitting? The y-axis. He's not touching the x, is he? Yeah, so it's just the branch it's just the axis the branch hits. All right. All right, try that one. There's a more normal one. So, graph it, huh? Make the graph of that thing. So draw a little picture. What's the center of this one? 0, 0, right? Because there's no number next to x, add or subtract next to x or y. Center is 0, 0. Good. I'll wander around. Feel free to talk with those around you. See if you're getting the same stuff. Let me know if I can help. Yeah, so then they want you to find the center, transverse axis, vertices, stuff. Yeah, so if you got the picture, then just go ahead and find all the stuff they're asking for. The center, the transverse axis, the vertices, the foci, the asymptotes. Yeah. Yeah. That's definitely there. You got it. What's that? Yeah, yes, if x versus right left. Yes, you're correct. You're correct. Now, so these are branches right left, aren't they? Because x is in the front there? Oh, yeah, one's parentheses. Because to write it like that means only the root 2 squared, not the 4. So that'd be different. Yeah, because you have to do square the whole thing.
Oh, okay.
Yeah, right. That makes sense. They're not to be picky. That's a different meaning. Does that make sense?
Yeah.
If the 2 is just if there's no parentheses, you're not squaring the 4. You're just squaring the root 2.
Oh, okay.
So that makes sense. You got to square the whole thing. The formula said a squared, and a is 4 root 2. So the whole thing has to be squared. Or you can just make that 32 on the bottom. That's what 4 root 2 squared is.
32.
It's
Oh,
plain 32. Either way. Yeah, they get those folks, you get the vertices and the foci
I
points.
think this is square root 32.
Is there a guy?
No, just 32.
Just 32?
Yeah.
No root. Oh, but you mean 32 square root? Just 32?
Yeah, just 32. 32 squared.
Yeah,
We don't
square.
I don't think you need to put a root there. Because the answer that you have for 6.4 is 32.
So just like that.
Okay.
I think so, yeah.
I was like confused what we did with the y. So we would make a really big box then.
How so? One thing I'm so nervous.
Do we do
Wow.
It was so that's the easier.
this one they gave it to us.
I'm so mad. So that's one of them. I got the same question on this.
Well, the first one is yes.
Let me try doing oh, that's on the y-axis. Use the y comes first, right?
No, you don't have the same one. Oh, yeah. It says
I know.
Yes, because these are just so I mean you can put like 9 or 49. You don't want
You should. Very solid.
oh, it's flat. Oh. What's that? I mean, that's something.
You don't want to talk about it. You don't want to talk about it.
I didn't think it would be that awesome. Well, I think it's like great.
I think it was better than the same. You don't improve your homework.
Yeah.
So you know how like this was due a long time ago? Like something like that. So you have to go back to school while you're school.
Even if you don't.
Even if it's not on time. I already did it. And then 1%, that was the
Yeah, because also we don't
improve my score. This instructor has allowed me to improve your score.
So you just leave it. Just like a
Yeah. And we'll just go over the test day. Because that test day shuts down. So you have to. So I'm going to go to Tourist. I'm going to eat first, but then Tourist Center all day stay there. And we're going to help with all my homework. It's better than just me doing it. There's like 3 or 4 brains helping me do it.
yeah, that's why
I think they're good. Well, I have favorites there. There's one Asian girl. She's really good. She's like skinny and stuff. And there's one tall guy, very tall. I miss him. He's like 6'4" or something. He's very good. There's some people that are not good, and I don't even raise my hand when they come towards me. But and then they'll like come towards me. They're like, "Oh, do you need help?" I'm like, "Oh yeah, not for me." I know, I kind of feel bad sometimes.
You don't want to give you your phone like a right?
Yeah, because I don't want to waste my time with you.
that is nice.
I just like, I got it wrong and put on.
Okay, are we ready? So, whatever's in the front tells you whether it's right, left, or up, down, huh? If there's X in the front, the branches go right, left. If there's Y in the front, the branches go up, down. So this one goes right, left. Okay, and I should make that 9 into 3 squared, and that 49 into 7 squared, like that. Yeah, whatever's in the front, huh? X, transverse axis is X. Going to hit the X-axis, totally. Good. So whatever's underneath X, that's right, left. So I go right 3, 1, 2, 3. Left 3, 1, 2, 3. Put a dot, put a dot. This is under Y, so it's up, down, right? Up 7, 3, 4, 5, 6, 7. Put a dot. 1, 2, 3, 4, 5, 6, 7. Put a dot. Everybody good so far? Whatever's underneath X is right, left. Put dots. Under Y, up, down, put dots. Make a dotted box, huh? Make a dotted box. so. And then fill in the diagonals. Go right through the center. Let the diagonals shoot out the ends. We all good with this basic setup? So it's just like the ellipse, huh? You guys did the ellipse homework last night? It's just like the ellipse. Whatever's underneath X is right, left. Whatever's underneath Y is up, down. But then instead of making an oval with these 4 dots, we make a dotted box and fill in the diagonals, which are the asymptote lines. See how it's very, very similar? Right? If we were graphing an ellipse, it would be x squared over 9 plus y squared. That's all they would need to change. It would be an ellipse equation, huh? But I would do all the same stuff at the first. I would go, look, 3 squared, 7 squared. This is underneath x, right, left 3. I'd go right 3, left 3. This is under y, up 7, down 7. And then I would just make an oval connecting those 4 dots, wouldn't I? And I'd be done. So whereas with a hyperbola, because we have minus in the middle, it's a hyperbola, I go ahead and make a dotted box, fill in the diagonals. Those are my asymptote lines. And now, where do the branches go? Either right, left, or up, down. We already said with x in the front, it's right, left. So it starts right in the middle of the box. They always start in the middle. Goes up. The asymptote lines are like guidelines guiding the branches. Right, left. Now, if y was in the front, I would have done branches on the top of the box and the bottom of the box, also starting in the middle. All right, so there we go. Now, can we answer all the questions? Transverse axis, that's the x-axis. Right, see how the branches are touching the x-axis? They never touch the y. They're going right, left, either way you want to think about it, x. What are the vertices? They want coordinates here. What's this dot and this dot? Remember, vertices are the places it hits. So what's the coordinates? Over and up, over 3, up 0, back 3, up 0. So those are the vertices. Over 3, up 0, back 3, up 0. What are the foci points? Foci are like further here and further here. They're inside the branches, aren't they? Focus points are always inside. So how do we find them? Got to use the focus equation. So you know the focus equation is Pythagorean, right? Whatever sign is in the original, minus in the original, opposite in the focus, plus in the focus. It's the actual Pythagorean. All right, what's a squared and b squared? It's these guys. A and b are the numbers underneath x and y, aren't they? So 3 squared plus 7 squared is c squared. A and b are the numbers under x and y. 9, 49 is c squared. 58 is c squared. And that means root it, plus or minus. So c is plus or minus root 58. You can try to simplify that root 58. It's not going to simplify, right? If I took 58 and I tried to break it down, it would be 2 times 29. And 29 doesn't break down further. So there's not 2 of anything. I can't send anything out, right? So it just stays root 58. All right, so what do I do though? They don't want me just to say root 58. They want coordinates. So what's the coordinates of this point? It's over, right? Root 58 up 0. And this point is back root 58 up 0. Those are the 2 focus points. We good? Root 58 0, comma. Minus root 58 0. Minus root 58 0. Good. Okay, finally, asymptote lines. Asymptotes. So now I need the equation. I haven't spent much time talking to you about this. Let's find the equations of the asymptotes. I don't know where to squeeze it in here. So to find that'd be, this line right here and this other line right there. How do you find the equations of those lines? Well, it's mx plus b, and the b is 0. See how they're hitting at the origin? So that means the b is 0. So the equation of that, I'm searching for space here. All right, so I'm going to erase this focus work if that's okay. And put it in right here. So to find the asymptote line equation, y equals mx. I don't need the b. The b is 0. These lines hit the y-axis at a height of 0. The b is 0. So what is the slope? How do I find? I've got to write the equation of these lines. Got to have the slope. Slope is rise over run. So what's the rise and what's the run? What's the rise? Yeah, whatever's underneath y. Remember that? That's been throughout for all these graphs, huh? Whatever's underneath y is rise, and whatever's underneath x is sideways. Again, Math Excel, if you click on the help button, does all this A and B and not A but B if A is bigger, and just skip all that. Just whatever's under y has got to be up, down. Whatever's underneath x got to be right, left, huh? So it's got to be 7 over 3. And you got to do plus or minus because one of the lines goes up, one line goes down. That handles them both. We're done. Rise over run. How are we doing? Questions I can answer? This making some sense? It's not a lot different from the ellipse. Some of the beginning part's the same. So if you didn't get that ellipse section or that parabola section, spend hours with Tim, or tutors in general. They help me. Come see me if you can. Math stars work for you. All right, I'll move on. Okay, let's try this one. So what's the deal with this one? See how they have the numbers in the parentheses with x and y? What does that mean about any graph? What does it mean? It's not, they moved the center. It's not the origin anymore, huh? That's where the new center, in fact, you guys tell me, what is the new center on that one? Yeah, opposite, huh? -4, 6. Everybody said that's the first thing to do. Oh, yeah, good job. Yeah, you're right. Yeah, so it's opposite, and that's the x, and opposite. So the center is going to be positive 6, -4. Yeah, I mixed it because x has to come first, then y. Right, good job. Good so far? That's the first thing. So this one's going to be all the same, except it's got a new center. So go ahead and make a graph. Remember, the graph really helps us. Go ahead and begin making the graph. Put that center down for starters. Don't forget to check with those around you if you're getting the same thing. So there's the center over 6 down 4. Good. So there's the center. So go ahead and make and look what's underneath x. That'll be right left from the center. Look what's underneath y. That'll be up down from the center. Make the dotted box. So put those 4 dots. Go up down, the right left from the center. Whatever's under x, whatever's under y. Yeah, I'm doing it right now. I'm just trying to figure it out.
Yeah, that's part of it.
I think
all right, so whatever's under y, that's 4 squared, right, is up, down. Up, down, so I go up 4, down 4. Okay, good. And then whatever's underneath x, 6 squared, that's x, so it's right, left. Go right 6, left 6. Good? And then make a dotted box. So everybody see what I did there? Does that make it just like the ellipses, huh? Just like the ellipses. Whatever is underneath y is up, down from the center. Whatever's underneath x is right, left from the center. Getting the hang of that? It's always that way. So whatever's underneath x is right, left from the center. Whatever's underneath y is up, down from the center. Make the dotted box. Fill in the diagonals. Because those are going to be our asymptote lines. Let the diagonals shoot out the corners. Like that. We good? And now, where do the branches go? Are the branches going up, down, or right, left? Yeah, whatever's in the front, huh? And then what's in the front is y on this one. So the branches go up, down, don't they? So put right in the center of the top, and branch going up, branch going down, and branches going down. Making sense? Questions I can answer so far? See, that's very similar to the ellipse. So whatever letter's in the front, y is the front, up, down. X is the front, right, left. Okay, now let's start. Now we're ready to answer all their questions. Let's go through all their questions. They want the center. What's the coordinates of the center? What's right here? 6 minus 4. Just like that, huh? 6 minus 4 is the center. Okay, next, they want the, what do they want? Transverse the axis. What axis? Oh, yeah, actually, let me help you with that one. Do you notice what axis? The transverse axis means the axis spearing through the middle of the shape. It's actually this axis. Do you see that? That's the axis is move. When you move the center, you move the axis. Do you see that? See how that axis spears through the middle of the branches? So that's the actual axis. It's not the x-axis. It's not the y-axis. When you move them off center, off the origin, you get a different axis. So anyway, what is the equation? They want the equation of that axis, that transverse axis. Where's it hitting? Look at where it hits one of the grid lines. Where does it hit? Right? It's right there. It hits the x-axis, doesn't it? Even though it's parallel to y, it actually hits right here at x is 6, doesn't it? So that's exactly what it is, x is 6. The axis is x is 6. That's the x equals 6 line. That's the line that goes through the x-axis at 6. Everybody see that? That's a little tricky. We haven't had one of those. Yeah. Oh, does it? Oh, well then forget all that stuff. Great. What does it say? It just says it's parallel to which one? So it's parallel to the y. Nice. Okay, good. I'm glad they're not pushing you that hard. That sounds good. Parallel to the y. Good. We'll just say parallel to the y. Who cares what other than that? Yeah, so same thing. Yeah, no, I'll make it harder on these guys. No. Parallel to the y. Parallel. Good. We won't worry about that other stuff. All right, so parallel to the y, the transverse axis, parallel to y. So basically, if it's going up, down, so it's going to be parallel to y. If it's going right, left, so it's going to be parallel to x. Good. Don't have to worry about that. Okay, next, vertices. Can you give they want the actual coordinates of the vertices. What are they? Well, this and this, these are the vertices, these big ones right there, right? Those are the vertices, places where it hits. Now, how do you find the coordinates of that when they're all weird and, off center and everything? Remember the way to do that? You take the center, which is right here, 6, -4, and you add and subtract how far you need to go from that center. To the correct coordinate, though. If you're going right and left, you got to abstract to the x coordinate. If you're going up, down, you got to abstract to the y coordinate. Don't you? You tracking with me? Okay. So to get this dot here, what do? We got to go up from the center. To get this dot here, we got to go what? Down from the center. So I'm going to take that 6, -4 right here. And how far? How far are we going up or down? Well, up or down, y. What's underneath y? 4. Remember, what's under y tells you how far up and down. So I got to add 4 and subtract 4, not 0. Subtract 4 from this y coordinate. You tracking with me? I've got to take the center coordinate, which has an x, an over, and an up, down. And I'm going up 4 and down 4. Why? Why up and down 4? Because that's what's underneath y. It's 4. Remember how that always tells you up and down in all these equations. So I'm going to add 4. What, -4 plus 4? 0, right? So that's going to be 6, 0. And the other one is going to be 6, -8, because it's -4, -4.
That'll be the.
Those are the two vertices. 6, 0, and 6, -8. Is that okay? See how we find those new vertices? We just take the coordinates of the center, we add and subtract 4, up 4, down 4, to the y value, because it's up, down. Okay, now what? What else do they want? Foci. They want the foci points. So let's find those. How do we find the two focus points? Where are they? Generally, where are they sitting? Where are they? Just, yeah, inside the branch thing. So it's like one of them's like sort of right there, and another one's going to be like sort of right there. Just have something to look at, right? They're generally sitting somewhere like that, right? Inside the branches. Now, so clearly they're up, down, aren't they? So how far up or down? Well, can you find that? Did you find that? Yeah, it comes from the focus equation, right? So we got to go to the focus equation. Let's do that focus equation. A squared plus b squared is c squared. Right, we use plus because there's minus in the main, plus in the focus. Always opposite. Always opposite. Whatever sign you have in the main equation, if you have minus in the main, you're going to have plus in the focus, aren't you? So here we go. What's a and b? Yeah, it's the 4 squared and the 6 squared, huh? Is c squared, so that's 16 and 36. So that's some big number. 52? 52, and then root it up and down the ladder. Can you simplify root 52? You can a little bit. It's going to be 2 root 13. Did you get that? If you break down the 52, it's 2 times 26, and 26 is 2 times 13. So I've got 2 2's. Remember, tell my algebra students, target, 2 for 1 deal. 2 2's in, 1 2 out. So it's plus or minus 2 root 13. So that's, let me give a little space here. It's plus or minus 2 root 13. Uh-oh. 2 root 13. Okay, now that's how far, though. That's not the coordinates yet. That's how far. You tracking with me? That's how far from the center to the focus points. Up 2 root 13 and down 2 root 13. So to find the actual coordinates of, say, like that focus point right there, what am I going to do? I got to start with the center again, don't I? I got to start with the center, which is 6 -4 right here, 6 -4, and I got to add 2 root 13 and subtract 2 root 13 to the y coordinate because I'm going up, down, not the x coordinate. You all tracking with me? See how I'm doing that? So this will become what? This point will become 6, -4 plus 2 root 13. And this will be 6, -4 minus 2 root 13, if you can read that down there. So I'll write it over here. 6, -4 plus 2 root 13, 6, -4 minus 2 root 13. We're done. No, they want the asymptotes too. One more thing. These things are long. So far, so good? Everybody see how I got that? Solve for the focus. And then when I found it was 2 root 13, use the a squared plus b squared is c squared. 2 root 13. And then again, see how I'm always messing with the, whenever they move the center to find stuff, you've got to go back to the new center. and add or subtract. If you're going up and down, you got to add or subtract to the y coordinate. If you're going right and left, you got to add or subtract to the x coordinate. You're only messing with one coordinate at a time. So I added 2 root 13 right here and subtracted 2 root 13 from the negative 4 y coordinate. So I got negative 4 plus 2 root 13, negative 4 minus 2 root 13 to the y coordinate. Is that making sense? Up and down is y coordinate. Okay, last thing, asymptote. It's actually pretty easy. The asymptote. Let me get this out of the way. The asymptote equation. How do we do the asymptote? It's always y equals mx, huh? Plus or minus rise over run x, mx. Plus or minus. It's always how you do the asymptote. So I don't have any room left. So I'm just going to erase the graph now.
Wouldn't there be a B though?
Wouldn't there be a what?
Wouldn't there be like a B because it's not?
Oh, yeah, let me help with that. Yeah, oh, I shouldn't have erased it because I could have shown it. Yeah, let me just tell you what you do. Here's what you do in y. You go plus or minus. Now, what's rise over run? So I'm doing the ask. Everybody with? Yeah, there is a trick here. Let me show you. Everybody with me on this? That's right. This one is harder. I forgot. It's got a little trick. But I'm going to make it super easy. I'm going to show you a way where you don't have to mess with b. You can do it super easy. Are you tracking with me? All right. So asymptote is plus or minus, right? One line goes up, one goes down. There's two asymptote lines, right? One going up, one going down, plus and minus. Slope, rise over run, mx plus b. Forget about the b for a minute. Just pretend it's centered at the origin for a minute. I have a tricky way to come in the back door and get it easy. What if these lines were really centered at the origin? They're not. I know. The center's been moved, whatever. We'll handle that in a minute. We're going to handle that at the end by just messing with the equation. We know how to move anything, right? Opposite, opposite. Done. So just pretend they're at 0, 0 in the beginning. What if they were really at 0, 0? You would do rise over run. Okay, where's rise and run? Where's rise and run? Yeah, y. Whatever's underneath y. Right? We've said this, we use this several times. Whatever's underneath y, that's rise, huh? That's up, down. So 4. What's underneath x? That's run. 6. We got to reduce that to be 2/3. But that's rise and run, basically, right? So there's rise and run. Let me make that 2/3. So plus or minus 2/3 x, right? Now, hold on. That's if it was centered at the origin. That's if the center was at the origin. But, right, it's if the two lines went right through the origin. But they don't. The two lines, I've erased the graph now, but they've been moved. Where have they been moved? Well, according to the center. They've been moved 6, negative 4. Well, how do you, whenever, anything, you guys have known since the second week of the class probably, how to move any graph. You just take the equation you've got, and then you go, oh, opposite of whatever x is, opposite of whatever y is. That handles a movement, doesn't it? So you just go next to x, you go, oh, x, you got a 6 there, I'm going to make that minus 6. And y? Y, you got a negative 4 there, I'm going to make you into y opposite, so plus 4. Done. That's all you got to do. Everybody see that? See how you just do the same thing you normally do, rise over run, y over x, and then you just shift it according to the center. The center's, 6, negative 4, just do opposite, opposite. So that center thing works for us all the time? Opposite, opposite.
Will it take that form, or do you want to?
I wonder. That's a good question. I think they want you to get y alone. So let me show you how you would do that. I mean, you can just move the 4 over, basically, right? But let me show you. Everybody good to there? So I'm going to go fresh screen here. Y, well, what was it? Plus 4? Y plus 4 plus minus 2 to the p. It is that form? Oh, good. Well, then I won't mess around. Is it? Well, great. All right, then I won't mess around. Oh, it'll be way different. No, I'm just kidding. Yeah, it'll be that form. We good then? We happy? Questions? I'm looking for your happiness here. Yeah, so good job recognizing when you see x squared and regular x or y squared regular x, complete square, huh? Just like we had to do this for the other two sections, same thing here for 10.2 and 10, whatever they were, 10.2 and 10.3, parabolas and ellipses, same thing here. So when you see, let me write that out again for you, when you see x squared and x to the first, or y squared and y to the first, you've got to do the whole complete the square thing. So remember, so there's certainly going to be, there's one complete the square question on the real exam. It'll be from one of these three sections. So you've got to know how to do that. But then put one example on the 3x5 card. This one's especially hard because of the minus sign. Let me remind you what you do. Step 1 is gather stuff. Gather x squared and regular x, y squared and regular y, and move the number to the other side. So you gather up some x's and y's and move the number to the other side. So let's jump that 9 to the other side, and then I've got y squared minus 4y minus 9x squared minus 18x, and I move that 9 to the other side, it becomes a plus 9. So far, so good. Just kind of organize things, you know. Just get the x stuff with the x stuff and the y stuff with the y stuff, and move the 9 to the other side. Okay, now, this is the extra tricky step. Remember how we have to factor out any number in front of x squared or y squared, even -1. Even -1. See, that's the trick. See this, or in this case, even if you have a -1, in this case we have a -9. But yeah, some of them they'll just give even. Yeah, let me show you what I mean. What if there was no 9 there? I would have to factor out -1 because that's really, if there's anything in front of x squared or y squared other than +1, basically, then you got to factor that out. Even if it's just a minus sign. Even if that was just minus sign, that's really a -1 in front of x squared, and you got to factor it out. So that's a trick here. So there's a -9 there, really. So what do I mean factor it out? I mean you got to go -9 with parentheses, like that. You know what I'm talking about? Whereas for the y, who cares? He just has a +1 in the front, so we don't have to mess with him. Oops, I'm off the screen there a little bit, huh? Move it over a little bit. So leave a blank. Now, what does that -18x become when I factor out that minus sign? I gotta put here whatever would be the same. So yeah, positive or negative? Positive, good. Positive 2x, huh? Because -9 times +2 goes back to -18x. Same thing. Good. So you remember that step? That's the trick. And we did that for ellipse as well, where you had to factor, but we didn't have negative. So it's a little extra wrinkle here. So whenever there's a number, again, a number in front of x squared or y squared, you have to factor that out before you do the magic number thing. That's
Is that -9? Is going to make a difference if we square it as well when we do our...
We'll see. Yeah, there's some stuff that'll happen. Yeah, it's a little problematic. So, okay, now remember how to find the magic number, I call it, the completing number, the number that'll make it factor perfectly. Middle number over 2 squared. Huh. Remember that? Middle number over 2 squared. So let's do that. Let's come right here. Here's the middle number. Over 2 squared, which is 2 squared, which is 4. Who cares about sign? It's going to end up positive in the end anyway, right? The completing numbers are always positive because they're squared. So don't worry about signs. So -4 over 2 is 2. Squared is 4. So that means I'm going to put a +4 here. And if you put a +4, a brand spanking new +4 on the left side, you got to put +4 on the right side of the equal sign to keep the balance, don't you? You good there? And now, what about x? Well, same thing. Over 1 squared, that's 2 squared, that's 4 also. So I got to put a +4 right there. Yeah. Oh yeah, what am I doing? Thanks. I'm being crazy. I'm glad you guys are paying attention. Yeah, I don't know why I did that. I'm just totally spacing out. Yeah, it's supposed to be over 2 squared, which is 1 squared, which is +1. Thank you. +1. Good. Right? So you take the middle number over 2 squared. Middle number over 2 squared. Right? That's how we find the completing number. Now, what do now when I added 4 to the left side, I had to add 4 to the right side. Now when I add 1 to the left side, be careful, huh? Yeah, that 1 is not just a 1, it's under the influence, right? That's a drunk driver right there. That plus 1 is under the influence of a negative 9, isn't it? It's not just plus 1, right? It's got something affecting it. It's got alcohol in its system. It's got something affecting it. Negative 9 times 1, it's under the influence of that negative 9. So really, if I was to multiply out this whole right side and go back to the way things were in the beginning, I would really end up with negative 9x squared, which is what I had in the beginning, and negative 18x, which is what I had in the beginning, and what? Negative 9 would be there. Really, there would be a brand spanking new negative 9 on the left side. By putting a plus 1 in this parenthesis under the influence of a negative 9, I really affected, truly and truly affected the left side by negative 9. So I've got to really and truly affect the right side also by negative 9, don't I? Got to do negative 9 on both sides. You got to do the same actual effect to both sides to keep the balance, right? These two things are equal. Treat them the same, still be equal. But you got to make sure you're really treating them the same. That really had a negative 9 effect on the left side. So I got to really affect the right side by negative 9. Everybody good with that? Remember that? So that's a little tricky. All right. The rest is more normal. So now we can go on with normal. What is, these three are guaranteed to factor. Remember, how do they factor? Y minus 2 squared. Right? Isn't that y minus 2 squared, those three? See, that completing number makes them factor. It makes them factor as a square. It completes them into a square. Gives them just what they need just to factor as a square. Minus 9. How do these three factor? X plus 1 squared, huh? If you were to FOIL that out. Right? What's the other side? 9 minus 9, it's 4. Oh, yeah, this one, it has a different wrinkle than I was thinking. But it has a wrinkle. Yeah, good so far? Is everybody good to there? How we doing? We good to there? So let me see what we got. Y minus, so I'm going to go to fresh screen if that's okay. Y minus 2 squared, what was it? Minus 9x plus 1 squared equals what? 4? Okay. So we good to there? I completed the square. Questions to this point? All right. What do you got to do now to finish getting him plastic surgery, giving him the look we need to graph? Divide by 4. Divide by 4. Divided by 4. That's normal enough. We always got to get a 1 on the right side. This one is no big deal. Here, it's going to be y minus 2 squared over 4. This is a 1. And this is 9x plus 1 squared over 4. Good? Now.
You know how this question started with the y squared was like minus like something x squared?
Right.
And when you prove them together, you did like the y squared minus the y.
Right.
If there's another problem that started with x squared, you start with x. Or with not the underneath how you prove it.
Right. Yeah.
Because my problem started with x squared.
Yeah, so x squared is going to go in the front. Yeah, so whatever's in the front goes in the front. They can switch around on you though. And you got to watch the signs.
Yeah.
So basically, whoever's positive has to end up in the front. And I don't have time to explain. Come out, so I'd be glad to help you. But if that's a negative on the right side, and you divide by a negative, their signs will change, and thus he would be the positive, and he would be the negative, and they would be the swap. The positive would need to go in the front. That's what I was trying to show you. I guess it's 21 or 20. I don't know. I tried to find it. Couldn't find it. And one of those days, there's a swap-a-roo happens. So I'd be glad to help you, tutor in, get help on that. Make sure you can do that. Anyway, this one has an extra trick. I don't know if you're seeing it. It's got more wrinkles to remove. Plastic surgery is not over. He does not have the look we want. Not quite. Why not? What's wrong with his look?
Don't we have to raise it to whatever?
Let me write. Maybe if you're a little rusty, it's x minus h or whatever squared over a squared minus y minus k squared over b squared equals 1. That's the look, right? You tell me, how does this not look the same as that? What's different? This guy is out of place. There's not supposed to be any numbers in the top. No numbers in the top. Right? The look we want says only give me numbers on the bottom. Don't give me any numbers in the top. I don't know what to do with numbers in the top. Right? We have got to get that 9 out of there somehow, don't we? Yeah, we could just erase it. No, but that would change the problem. We got to get it out of there legally. We got to get it out of there without really changing anything. How do you do it? How do you get that 9 out of there? I am probably using up way too much time. This is a very hard, picky problem. Probably I'm not going to give you one this hard on the test. To get that 9 out of there, there's several ways you can do it. I would just, how about we just divide by 9, divide by 9. Boom, he's 1. Right? Because you can do the same thing top, bottom, of fraction. I basically just divided top, bottom by, or multiplied by 1/9. Is that a better way to think about it? Whichever you prefer, it's the same thing. Right? I had a 9 here, I had a 4 here. You multiply top and bottom by 1/9. Bye-bye. Or divide them both by 9. Whatever you like better. It's the same thing. So, yeah, I'll probably go back to just the dividing one. Whatever you like. It's all the same thing. But, so I divided by 9, gone. So he's a 1 now, huh? So that's legal. I'm not changing anything. I'm doing the same thing top and bottom. You get in the hang of it. See how math and science is always playing this game? Don't change it, but make it look different. All these legal operations. There we go. Now it's got the look we like. Now it's ready to be graphed. Unfortunately, whoop, not 4 squared. Why did I make that squared? Well, actually, I'm supposed to make this 2 squared, huh? Why did I write cubed? I'm trying to move on. I need to be done with this section. And 4/9, that's 2/3 squared. That's your A and your B. Now we're about halfway through this problem. Now you got to go on to the graphing step, right?
How did you get 2/3?
It's 2/3 squared, notice. So 2 squared is 4, 3 squared is 9. Yeah, because remember the look, we have to write it as something squared. Is that good? That's rough, huh? So, see why these take your life if you want to learn them? That's it, math and science. It's not for the casual. All right, let's move on then.